We're now going to summarize the four types of conics that we can have in polar form. We have r equals e times p divided by 1 minus e cosine of theta. Recall, this is going to be a conic who has a directrix perpendicular to the polar axis, p units to the left of the pole. We could have r equals ep divided by 1 plus e cosine of theta. This is going to be a conic that has a directrix perpendicular to the polar axis, p units to the right of the pole. We have r equals ep divided by 1 plus e sine of theta. This is going to be a conic that has a directrix parallel to the polar axis, p units above the pole. And finally, we have r equals ep divided by 1 minus e sine of theta. This is a conic that has directrix parallel to the polar axis, p units below the pole. What we should notice is that when there's a sine function in the equation, the directrix is parallel to the polar axis. With a cosine, we have directrix perpendicular to the polar axis. Finally, let's talk about the eccentricity. If e equals 1, the conic's a parabola. The axis of symmetry is perpendicular to the directrix. If e is less than 1, the conic is an ellipse. The major axis is perpendicular to the directrix. Finally, if e is greater than 1, the conic is a hyperbola. The transverse axis is perpendicular to the directrix. So let's go ahead and do an example. We have r equals 6 divided by 3 plus 3 sine of theta. First thing we should notice is that this is not in standard form. I want this value right here to be equal to 1. I get this value equal to 1 by dividing both the numerator and denominator by 3. The result is 2 divided by 1 plus sine of theta. So what we should notice is that the polar equation has a sign in it, which means the directrix is going to be parallel to the polar axis, and because it's plus sine of theta, the directrix is going to be p units above the pole. What we need to do first is identify the values of e and p so that we can identify the type of conic that we have. Well, the coefficient on the sine curve, the coefficient on the sine expression is the value of e. Therefore, e is equal to 1. We also know that e times p is equal to 2. Because e equals 1, we know the conic is going to be a parabola. Because e times p is equal to 2, and we already know that e equals 1, that immediately implies that p is equal to 2. So the directrix is going to be parallel to the polar axis 2 units above the pole. So we know that I have a parabola. We know that the focus is going to be at the pole, and we know the directrix is 2 units above the pole, and again parallel to the polar axis. The midpoint between the focus and the directrix represents the vertex of our parabola. So the vertex is going to be at the point 1 comma pi over 2, because the vertex has to lie on the positive y-axis, if you will, and the midpoint between 0 and 2 is 1. So what we're going to do is use this fact, and then if I let theta equal to 0 and theta equal pi in this equation, I get 2 points to the left and right of the focus that will allow me to graph the parabola. So if I let theta equal 0, I get 2 over 1, or 2 comma 0. If I let theta equal pi, I also get r is 2, so I have 2 comma pi. So I use the fact that the vertex is at 1 comma pi over 2, and the fact that I have points 2 comma 0 and 2 comma pi to draw my parabola, and here's what we obtain. Again, I have the vertex labeled at 1 comma pi over 2. There's your directrix parallel to the polar axis, 2 units above the pole. with the focus labeled at the pole.